Now look at this example. A bag contains 3 pink candies and 7 green candies. So look at here. You have a bag, in total 10 candies. It means the number of events or elements in sample space is 10. 3 pink and 7 green. 2 candies are taken out from the bag one by one. It's the keyboard for multiplication rule, one by one, without replacement. But what is the meaning of sampling without replacement? We talked about it before. Sampling without replacement means that you take a candy out, you make a note of it, and then you put it to the side, and you cannot resample it again. So for example, if you take one pink out, then for the second try, there are 2 pink in the bag. So, find the probability that both candies are pink. A, the first candy is pink, and the event B is the second candy is pink, because they are taken one by one. One of them is called the first one, and another one is called the second one. So the probability of the first one is pink and the second one is pink, it means both of them are pinks. According to the multiplication formula, is the probability of the first one is pink multiplied by the probability of the second one is pink, given that the first one was pink. So look at here. The probability of first one pink and second one pink is the probability of first one pink multiplied by probability of second one pink, given that first one was pink. So in the first try we have 3 pink candies in the bag, and in total 10. So the probability of first pink is 3 divided by 10. But for the second try, because we know first one was pink, so in the second try we have 2 pink and 7 green. So in total 9. So the probability of second pink is 2 divided by 9. So the answer is 6 divided by 90. Find the probability that both candies are green. Okay, both are green it means the first green, the second green, according to the multiplication rule. We can write like this: the first green and the second green is the probability of first one green multiplied by second one green, given that first one was green. So in the first try, we have 10 candies in total and 7 in green. But for second try, because we put one green to the side, we have 6 green and 3 pink. Again, in total 9, but the number of greens is 6 from 9 candies. So the result is 42 divided by 90. Find the probability that the first one is pink and second one is green. First one pink, second green. So first one is pink and second green. So the first one is pink. So the probability of first is pink. The probability of second is green. Second one is green, given that first one was pink. So in the first try, we have 3 pink. So the first one is pink, is 3, and in total 10 candies. But for the second try, because the first one was pink, it means we have 2 pink and 7 green. It means in total again 9 candies, but the second one green is 7 green in 9 candies. So the answer is 21 divided by 90. Find the probability that the second one is pink. Please note that we don't have any information about the first one. For example, here, when both candies are greens, it means first one is green and the second one is green. In this part, we have that the first one is pink and second one is green. But here in number 4, we just have information about the color of the second one. The second one is pink. So we have to consider 2 cases for the first one. First one is maybe pink, or first one is maybe green. So the probability of second one pink we have to consider 2 cases. first, or it's better I write it with blue, first pink or first green. And we have information about the second one, so we know that the second is pink, and here first green, and again second pink, and instead of or we should write plus according to the sum principle. So we consider two cases for the first one. First one is pink or first one is green. Okay. First one is pink. So in first try we have 10 candies in total and 3 pink. Second one is pink. In the second try, because we put one pink candies to the side, we have 2 pink candies and in total 9. Or again, or it means from the beginning, again first try, we have 10 candies in the bag, 3 pinks and 7 greens. First green, it means we have 10 in total, 7 green, and second pink, it means because the first one was green, we still have 3 pinks in the bag, but in total, because we put one green candy to the side, so in total we have 9 candies. So the answer is 6 plus 21, 27 divided by 90. Find the probability that one of them is pink and another one is green. What is the difference between number 3 and number 5? In number 3, we know that the first one is pink and second one in green, but in the in number 5, we just know one of them is pink. We don't know pink is the first one or is in the second one. So, and another one is green. We don't know that green is the first one or green is the second one. So, again, we have to consider two cases. So, the probability of one pink and one green is the probability of first, second, first, second. Okay, it's the probability of first pink. First one is pink and second one is green, or the probability of first one is green and second one is pink, and instead of or we have plus. So first pink, it means in the first try we have in total 10 and the number of pinks is 3, but second green, it means we still have 7 green candies in the bag, but in total 9. Or it means plus. Again from the beginning. First green, it means 7 from 10. Second pink, it means because the first one was green, it means we still have all the 3 pink candies in the bag, so we have 3. But in total we have 9 candies in the bag because we put 1 green candies to the side. So the result is 42 divided by 9. Now look at this exercise 58 from your textbook, page 83. At a gas station, 40% of the customers use regular gas, 35% use mid-grade gas, and 25% use premium gas. Of those customers using regular gas, only 30% fill their tanks. Of those customers using mid-grade gas, 60% fill their tanks, whereas of those using premium, 50% fill their tanks. Okay, we have 4 different events here. A1 using regular gas, A2 using mid-grade gas, A3 using premium gas, and B is the events of filling tanks. So look at these 3 diagrams. What is the probability of A1? What is the probability of using regular gas? You can see here, using customers use regular gas is 40%. So the probability of using regular gas is 40% or 0.4. But what is the probability of A2? 30% use mid-grade gas. So the probability of using mid-grade gas is 0.35 or 35%. What is the probability of using premium gas? 25% of customers use premium gas. So the probability of using premium gas is 25%. You can see that the summations of these probabilities is 1. It means in total there are three kinds of gas in this gas station. 40% of customers use regular one, 30% use mid-grade one, and 25% use a premium one, and in total 100%. Okay, of those customers using regular gas, only 30% fill their tanks. It's a conditional probability. Look at here, you have additional information here. You can see that you know about the kind of gas that customers use. So you know about the kind of gas. So the probability of filling tank, given that using regular gas, is 30%. So this sentence is a conditional probability. The probability of filling tanks, given that using regular gas, is 30%. Again, of those customers using mid-grade gas, 60% fill their tanks. So the probability of filling tanks if customer use a mid-grade gas is 60%. It's a conditional probability. And those using premium, 50% fill their tanks. So if they use premium, 50% fill their tanks. You can see that it's a conditional probability. So the probability of filling tanks, given that using premium gas, is 50%. Now we are going to calculate these probabilities. What is these probabilities? The probability of using regular gas and filling tanks. It means a customer use regular tanks and also fill use the regular gas and also fill the tanks. So the probability of A1 intersection B is the probability of A1. The first one is gas, because at first you decide to use which kind of gas, and then you make a decision about filling your tank. So the first decision is about the gas, and the second decision is about filling the tank. So the first one here is A1. So the probability of using regular gas and fills the tank is the probability of using regular gas multiplied by the probability of filling tanks, given that using a regular gas. So we have this probability in the tree diagram. So by multiplying these two values, we can obtain this probability, the probability of A1 and B. Now what is the probability of A2 and B? It means using mid-grade gas and filling tank. So the first decision is about the kind of gas, and the second decision is about filling tanks. So again, the probability of using mid-grade gas multiplied by filling tanks, the probability of filling tanks, given that using a mid-grade gas. So again, by multiplying these two values, we can obtain the probability of intersection of A2 and B. But what is the probability of using premium gas and filling tank? It's the probability of using premium gas multiplied by probability of filling tanks, given that using premium gas. So again, you can see by multiplying these two values, you can obtain this probability.